This video is going to show you 4 different examples of how to solve for an unknown variable that is within an exponential equation. So let's take a look at the first one here. It says solve for x, and we've got 3 to the exponent 2x plus 1 equals 3 to the exponent 9. And the important observation here is that we have the same base on both sides of the equal sign. So that is the key, and as soon as we see the same base exists, we can now say, well, the only way that that could ever be true is that if 2x plus 1 was equal to 9, that is, if the exponents were also identical. We know the bases are the same, so if the exponents are the same, then the equation is in balance. So once we can identify that the bases are the same, we just write the expression or the equation that you see below, where I take the exponent from one side and make it equal to the exponent on the other side, and then simply solving, we just walk through as we would normally, and we'll say 2x equals 8, and then x equals 4. Okay, so really quick, really simple. All right, take a look at the second example here. Very similar. We have exponents with variables within them. And the only difference is that we can see that this base and this base do not match. Okay, we've got 2 and we've got 16. So in this case, we're going to have to substitute 16 with a power of 2, and that will make the bases match. So we're going to remove 16 and replace it with a power of 2. In some equations, when you're solving, you might have to actually replace both bases. You might have something where they have nothing in common, so you have to find a third base that you could substitute in for both as a power. But in this case, we can clearly see that 16 can be expressed as a power of 2, which is the other base. And so I'm just going to remove the 16, and we'll replace that with 2 to the exponent 4. Okay, the rest of the equation is going to remain exactly the same. We have 2 to the exponent 5x minus 1 equals 2 to the exponent 4, and that was raised to the exponent x plus 2. Okay, well, we're almost ready to rewrite the equation with just the exponents, but I just need to combine these two exponents together first, and then we can go ahead and complete the solution. So I'm going to get 2 to the exponent 5x minus 1 equals 2 to the exponent, and we're just going to go ahead and apply the distributive property. We know that we multiply the exponents when we have an exponent raised to another exponent. So this is going to be 2, and 4x is the first term, and then 8 is the second. Okay, so now we're ready to write just the exponents. 5x minus 1 must equal 4x plus 8 for that to be true. Now collecting all the x's on one side and all the constant values on the other, we see that x must equal 9. And we can always go back and check our solution. We can just take x equals 9, substitute it back into the original equations, left side and right side, and you can actually see if you have the right answer. Okay, well, let's move on and take a look at 2 more examples. Okay, in these 2 examples, on the one on the left, we have just a single term that contains the unknown variable x in the exponent. But you can see that it is not sort of all by itself on one side. That is, we have it being multiplied by 3, 2 is being subtracted. So what we're going to do is we're going to go ahead and try and get this base with this exponent all by itself by collecting all of the other terms on the other side. So 3, 4, x over 2 equals 48, and then 4x over 2 is equal to 48 divided by 3, which is 16. Now with that sitting there, now we can go ahead and say, well, wait a minute, if I'm going to write the exponents equal to each other, these bases have to be identical. So let's substitute a power of 4 in for 16, and that means that 4 x over 2 is going to equal 4 squared, because 16 is obviously equal to 4 squared. Once I've got that, now I can just write the exponents. And that leads me to the answer of x equals 4. Okay. Again, I can check my answer. I can substitute this back into the original equation. On the left side, if I actually put 4 into x, I would get 4 divided by 2. That is 2. 4 squared is 16. 16 times 3 is 48. 48 minus 2 is 46. So that works out perfectly. All right, last example. Again, the bases are not identical. So I'm going to leave the exponent of x squared plus 2x on this side, and then I'm going to substitute a power of 5 in for 125, and that is 5 to the exponent 3. All right, now that the bases are identical, we can just write the exponents equal to each other. And we notice that when we do that, we actually have a quadratic here. So we know how to solve for a quadratic. That is what we're doing here, solving for x. We can just move everything over to the one side. So minus 3 equals 0. And then we'll go ahead and factor. I know that the factors of 3 are 3 and 1. So I'm going to have an x and a 3 and an x and a 1. 1 is going to be positive, 1 is going to be negative because it's negative 3. And when I add them, I need more positives. That is, I need positive 2. So I will put the positive sign with the 3, negative with the 1. And now we can go ahead and we can solve for this. So x equals negative 3 or x equals positive 1. So in this case, there are two solutions for x. Okay, so there are 4 quick examples that show you how to solve for a variable in the exponent. The first sort of key rule that you need is you need to make sure that the bases are the same. Once the bases are the same, then you can rewrite with just the exponents. One exponent equals the other. You may have to substitute values in to get the bases lined up, and you also may need to rearrange or isolate a base, or in fact you may need to use some of your factoring skills to come up with the final answer.